Now here next point is methods of solving differential equation. Now recall what we did so far. If you remember, first we have started with differential equation, right? Any equation that contains derivatives is called a differential equation. Then we have discussed the solution of a differential equation, general and particular. Then in one of the exercise you had both differential equation and solution, and you have verified that this is a solution of this differential equation. Fine. You had both, I repeat, solution as well as differential equation, and you have verified that this is a solution of differential equation. Then in the next exercise, what you did is you were given the solution, that's a previous exercise, and you got the differential equation. That was the previous exercise, differential equation. How we were getting the differential equation? By differentiation. How many times we were differentiating equals to the number of arbitrary constants. Fine. So that was the previous exercise. From the solution you get the differential equation. Now here, now onwards in the next three exercises, that is in 9.4, 9.5 and 9.6, we want to do a single thing. Which thing? From the differential equation we get the solution. This is what we want to do. This is our task. Everywhere you will be given a differential equation and you want to get the solution. Now you recall the previous exercise. From solution you were getting differential equation by differentiation. Now you want to do the reverse of differentiation. So now which procedure should be used here? Integration, you know. So from the differential equation, if you want to get the solution, you need to use integration. Fine. So with the help of integration, we get the solution from the differential equation. That is about the next three exercises. So in the next three exercises, everywhere you will be given a differential equation. In these three exercises, you will be given a differential equation. And we use integration. What we do? We use integration. You know integration very well. And we get the solution. Get the solution. This is what we want to do. That's all in all about the next three exercises. Everywhere you have a differential equation. आपको solution चाहिए. So you want the equation which is free from derivatives. So what is to be done? That's integration should be done to remove the differentiation. Antiderivative procedure, that is which procedure? Integration procedure should be used to get the solution. Fine. Okay. So now for this here, the first thing we'll have the differential equation of the first order and first degree only, remember. First order and first degree. What's the meaning of first order? That means maximum dy by dx ही होगा. And degree क्या होगी? So power will be maximum like raised to 1. इतना ही होगा. First order and first degree. Okay. And now we have here three methods. First method is here. It is known as method of variable separable. Method of variables separable. Variables separable. Method of variable separable. That's one method. The second method, it is called homogeneous differential equation. Homogeneous differential equation. Homogeneous differential equation. That's the second method. And third method, that is known as here linear differential equation. Linear differential equation. How many methods we have? Three methods. I repeat, what are those? Methods of variable separable. The second one is homogeneous differential equation, and third one is linear differential equation. What is most important one here? Remember, integration. Methods are very simple. You will realize once I start doing. To do the methods is not a big task. What is important task? Integration. So you must revise frequently integration, then you can do. You know, applications of derivative was also dependent on integration. This chapter is also purely depends on integration. Fine. Okay, so we'll go for the first method, methods of variable separable, and that's, I think, next exercise, that is 9.4. Now before I go for exercise 9.4, let me just tell you what is this method. So here first method is method of variable separable. So what we do in this method we separate the variables. How will separate the variables? With dy you collect all the terms having variable y, and with dx you collect all the terms having variable x, and then you integrate variable x. I repeat, what we'll do? With dy we collect all the terms having variable y. dy के साथ आप सब y वाले terms ले लो. That is what you are separating variables. With dx you collect all the terms having variable x, and then you integrate it. You will get the required solution. We get the solution. Solution means what? An equation about variables and constant, remember. Right? It should be free from derivatives, you know. Okay, so let's go for first question, exercise 9.4. Very simple exercise. The only important concept is concept of integration, remember. For each of the following differential equations in exercise 1 to 10, find the general solution. Question number 1 here. You can see that this is a differential equation of the first order and first degree. Is it? Why this is a differential equation? This is a differential equation. क्यों? क्योंकि derivative is involved. What's the order of this one? 1. क्योंकि dy by dx. What's the degree of this one? 1. आपके सिलेबस में ही है, इससे ज़्यादा कुछ भी नहीं होगा. d square y by dx square ऐसे सम सब्जेक्टिव में नहीं होगा. Remember, might be in MCQs you may have such questions, but not in subjective. Okay. ये आप जानते हैं. What is this? Recall trigger. क्या है? Once you write the expression, immediately you should recall this 10 square x by 2. Right? Now we separate the variable. ये पूरा x का टर्म है तो dx को इस साइड ले लो. So dy equals to 10 square x by 2 dx. This is called VS form. In short, we will call which form? VS form. Variable separable form हो गया. With dx you have an expression about variable x. With dy we have constant. You can call it 1. Now what's the next step? Integration. So integrate it. हम लोग वहाँ पे क्या लिखते थे? Differentiation. Here integrating. So integral of 1 with respect to y, integral of 10 square x by 2 the whole dx. एक क्वेश्चन होगा माइंड में, क्यों ऐसा सेपरेट किया वेरिएबल्स? बिकॉज आप जानते हैं इंटीग्रेशन में मिक्स्ड वेरिएबल्स नहीं चलते हैं. दैट्स वाई. व्हाट इज द इंटीग्रल ऑफ y? 1 with respect to y, that is just y. You know that 10 square cannot be integrated directly. How do we integrate 10 square? 6 square x by 2 minus 1. आप जानते हैं. This is one of the points to remember from the integration. अब now this is not the question of इसके बाद this is not the question of differential equation. ये question of integration हो गया. What's the integral of 10 square x by 2? 6 square x by 2, that is 10 x by 2 upon coefficient of this, which is into 2. What's the integral of 1 plus constant of the integration? Right? You know that this is c is arbitrary constant. एक ही arbitrary constant आएगा क्योंकि आपके पास differential equation का order एक ही है. So this is a general solution. Why it is a general solution? Number of arbitrary constants equals to the order of the differential equation. Fine. आप reverse कर सकते हैं. You get the dy by dx from this. Place here you will get the RHS. That's what we did in earlier exercises. You know. Fine. Clear everybody? Okay. Next question. Question number 2. Second question. What is that question? dy by dx equals to root of 4 minus y square. Right. Where y should be between minus 2 and 2. Otherwise this become a complex number. How will solve this? By variable separable technique, you know. Okay. So here what we do? We separate the variables. Separate the variables means what? With dx you collect all the terms having variable x, and with dy you collect all the terms having variable y. Okay, so that's what I'm doing now. So here this is term involving y, so I'll take with dy. So 1 upon root of 4 minus y square dy. dy को आप डिनोमिनेटर में नहीं ले सकते, आप जानते हैं. You cannot take dy over here. Equals to, now dx on that side equals to dx. कौन सा फॉर्म हो गया? vs फॉर्म हो गया, वेरिएबल सेपरेबल फॉर्म हो गया. नाउ इंटीग्रेट इट, फिनिश्ड. डिफरेंशियल इक्वेशन चैप्टर का काम खत्म हो गया. अब आपका इंटीग्रेशन का काम चालू हो गया. रिमेंबर, एट दिस प्लेस माय जॉब इज ओवर. आपको इंटीग्रेशन आना चाहिए. नहीं आ रहा है तो रिवाइज द इंटीग्रेशन चैप्टर अगेन बाय डूइंग राइटिंग प्रैक्टिस. Okay, what is this? Can you recall? This is a square minus x square. If you remember, it is sine inverse x by a. A is 2 here because 4 you can write 2 square. आप जानते हैं. Equals to, what's the integral of here? 1. Integral of 1 is x and plus the constant of the integration. If you want, आप इससे छोड़ सकते हैं, but if you want to do one more step, y by 2 equals to, take sine inverse on the other side. So sine of x plus c, and therefore y equals to 2 times sine of x plus c is required solution. Is required solution. क्यों ये solution हो गया? Because it contains variables and constant. देखो एक arbitrary constant है अंदर. क्यों एक आर्बिट्री कांस्टेंट है? आई एम जस्ट रिवाइजिंग यू फ्रीक्वेंटली, रिमेंबर, क्योंकि डिफरेंशियल इक्वेशन का ऑर्डर 1 है. फाइन. चलो नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 3. बस ये हर बार ये एक ही चीज़ करना है आपको. dy बाई डी एक्स प्लस वाई इक्वल्स टू 1. व्हाट वी डू? सेपरेट द वेरिएबल्स. कैसे सेपरेट करेंगे? पहले सब एक साइड कर दो. So dy by dx equals to 1 minus y. Now ये पूरा y का टर्म बोल सकते हैं आप. So I'll take this expression over here with dy. So 1 upon 1 minus y into dy. I'll take dx over here. So dx. It is which form now? Vs form. Variable separable form, remember. This is which form? Variable separable form. Now what is the next step? Integration. So integrate it. Your next step is integration. So let's integrate this. Integrating. Can you tell me what's the integral of the first term here? It is like 1 upon y. This is a linear function, you know. A linear function है, आप जानते हैं. So you can imagine this is like y. What's the integral of y? Log of mod of 1 minus y upon the coefficient of x, which is minus 1. Equals to, what's the integral of here 1, which is x plus c. Understood? It's like integral of 1 upon x. What's the integral of 1 upon x? You know here integral of 1 upon x is nothing but what? Log of mod of 1 minus y, remember. Fine. Now You can simplify further if you want, otherwise you can leave in this form. See, I can rewrite like this, equals to log of 1 minus y equals to, here you can write here minus x minus c. I'll drop the log function, so 1 minus y is equal to e raised to minus x minus c. You know, ये आपको पता है, this is one of the property of the log function. If you have log y equals to x, nothing means b is easy. So if I drop the log function, you know y equals to e raised to x, exponential and logarithmic functions. You know it. So what I did, I have eliminated log from here, right? So you have e raised to this right hand side expression. And now here further you just express in form of y here. So what is y here? I can write 1 minus e raised to minus x into e raised to minus c equals to y. And if you just compare with backside answer, you can call this as some new constant a. So 1 plus a into e raised to minus x equals to y. This is your backside answer, a required solution. But what I'm trying to tell you is, you can just leave here also and you can say that this is a required solution. यहाँ पे आप छोड़ सकते थे. You could have written here also, a required solution. It will do. It's okay, fine. But अगर MCQ में है तो आपको ये आना चाहिए. Remember, that's why I've shown for you. आप subjective में whether you write this or this, both are absolutely correct. Remember, where what is a क्या है? Minus e raised to minus c. Remember, this is arbitrary constant. Clear? Okay. Chalo, next question. So sometimes this happens in questions of differential equation. आप यहाँ पे छोड़ देंगे और पीछे आंसर देखेंगे तो it might looks different, but ultimately they are same. Remember. Question number 4. Fourth question. Okay. Sec square x into 10y into dx plus sec square y into 10x into dy equals to 0. So we separate the variables. You know how do we separate the variables? dx के बाजू में सब x वाला टर्म आना चाहिए. So what I'll do, I'll take this 10 down here. ये 10 को नीचे ले लो. Ensure dividing by 10. You must realize. So sec square x by 10x dx plus this x square y as it is here, and I'll take this 10 down, so 10y dy equals to 0. So it is which form? Variable separable form. AVS form हो गया. This is VS form. Now next step, integration, right? This is the only important point, which is about differential equation chapter. अब तो आपका काम चालू हो गया. My job is over now, right? अगर ये नहीं आ रहा है तो it doesn't mean that कि आपको differential equation नहीं आ रहा है. It means you need more practice of integration. Remember, understood? By just observing the integral, you must capable to answer. नहीं आ रहा है तो do the practice. I'm sure you can do it. चलो, can you tell me it is which form? Can you just recall? By writing the question you must realize कौन सा form है? F dash upon f. This is f dash, this is f. You know answer, log of mode of denominator expression plus here log of mode of denominator expression. Derivative of constant, you know, derivative of 0, constant is 0. So what's the integral of any constant, any 0? That's a constant. Now दोनों जगह पे log है तो I'll write log c as the constant. I repeat, integral of 0 is constant, so आप c भी लिख सकते हैं, but at both the places I have log, so I wrote the log c. take the log common, so you know that the addition becomes into equals to log c. Now eliminate the log function from both the sides, so 10x into 10y equals to c. Required solution. Clear? Understood? Normally throughout all the terms, if your log function, हम लोग normally constant c के जगह पे क्या लिखते हैं, log c लिखते हैं, remember, right? आप ना लिखो तो भी wrong नहीं है, don't worry about it. शायद पीछे आंसर मैच करने में प्रॉब्लम होगा, but it will not be wrong, don't worry about it. Fine? Okay. चलो next question, fifth question. Question number 5. Let's do that. The next question is this: e raised to x plus e raised to minus x into dy minus into dx equals to 0. We separate the variables. Kaise? You see, these both the expressions are about what? You know that both are about variables x. So this should be with dx, remember. So I'll take this down here. So dy equals to e raised to x minus e raised to minus x upon this. I have dropped one step here, you must realize. कौन सा फॉर्म हो गया, ABS फॉर्म हो गया, वेरिएबल सेपरेबल फॉर्म हो गया आपका. Fine, understood. Just to take this one over here and change the side, you will get this. Now integration. So integrating. क्यों इंटीग्रेशन कर रहे हो आपको पता है, वी वांट टू मेक इट फ्री फ्रॉम डेरिवेटिव्स, सो इंटीग्रेशन ही करना पड़ेगा. सो हियर इंटीग्रल ऑफ y 1 विथ रिस्पेक्ट टू y e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x dx. How will integrate right hand side integral? ये आप जानते हैं. This is f and what is this f dash. So what is the integral of that? Your integral is just y. Integral of 1 with respect to y, that is y. ये कौन सा फॉर्म हो गया, log of mode of denominator expression. आप जानते हैं, this is very well known formula, right? You know this. Integral of f dash upon f, log of mode of denominator expression plus the constant. Okay. Now here you can leave like this, or if you want you can simplify also. इस साइड लेके log हटा सकते हैं, otherwise you can leave like this, not an issue. Which is required solution, which is required general solution. Remember, क्यों general solution बोल रहे हैं आप जानते हैं. Number of arbitrary constants equals to ऑर्डर ऑफ द डिफरेंशियल इक्वेशन. आर्बिट्ररी कांस्टेंट एक है और इसका ऑर्डर भी 1 है क्योंकि dy बाई dx ही है. फाइन, चलो नेक्स्ट क्वेश्चन, सिक्स्थ. आई जस्ट एक्सप्रेस इन फॉर्म ऑफ वेरिएबल सेपरेबल्स एंड देन you can integrate it. I'm sure you can do it. Check the backside answer then. How will separate the variables? Very simple. dy के साथ a वाला टर्म होना चाहिए, तो टेक इट डाउन. 1 upon y square plus 1 into dy and this should be with dx, तो dx को इस साइड ले रहा हूँ. This is vs form, variable separable form. Now we integrate it. Variable separation हो गया, integrating. Can you recall what's the integral of this? ये क्या है? You know that this is nothing but what? tan inverse y. tan inverse y का डेरिवेटिव याद करो, आपको ये मिलेगा. Equals to 1 plus x square plus c. That's a required solution. You can write it. Sorry, integral of 1 is x, here x cube by 3. Integration करना पड़ेगा ना, I wrote it directly by mistake. This is a required solution. Required solution here. Where what is the c? C is arbitrary constant. Okay. Next question. question number here 7th. In the 7th question, you have y into log y dx minus x dy equals to 0. Right. So you must have noticed here, you see this is about a variable y, this is about a variable x. So take x down, y dy over here. So I'm just doing that here, dividing by x. So 1 by x equals to, I'll take this one over here, 1 by y into log y here into dy. Variable separable form. I've just separated the variables, remember. ये आपको अब आना चाहिए because we did 6 questions. Okay. Now next step is integration. So we integrate this, integrating. What's the integral of here 1 upon x? You know. इसका कैसे करेंगे? That's really good task. How will integrate this? Can you think? एक easiest method है log y को t ले लो. You know, log और exponential कोई भी integration का समय है t ले लो. The another easier way is what I'll do. I'll take y in the numerator. I'll write just like this. Right. So without substitution you can do. Now you notice what's the right hand side integral? It is in the form of f dash upon f. Is it? This is f and this is f dash. This is f dash, this is f. So how will integrate this? Here this is log of mode of denominator expression. What is the right hand side? It is also f dash upon f form. So कैसे लिखेंगे? This is log of mode of denominator expression, that is log y. Got it? And constant of the integration. दोनों जगह पे you know आपके पास what we call log है, तो यहाँ पे log c लिखना चाहिए. Correct? Is it? आप c लिखो तो भी चलेगा, not an issue. Now I'll just eliminate the log function. आप ये दोनों में से log कॉमन ले लो तो बीच में into हो जाएगा, c into log y हो जाए. Now drop the log function, we assume that this is positive. So x equals to here a log निकल जाएगा, I'm sorry. So here we'll get the x equals to c into log y. You can write this as a required solution. Right? C is arbitrary constant. Required solution. पीछे जो आंसर दिया है वो it looks little bit different. वो फॉर्म में भी आप कर सकते हैं. कैसे देखो, if you want to convert, this is correct. आप यहाँ तक छोड़ देंगे तो it's not wrong. Remember, I'm just trying to get the backside answer. Okay, so what I'll do, I'll take c down. 1 by cx equals to log y. You can call here this as some new constant c dash. Now log वापस हटा दो तो e raised to c dash into x equals to y. Right. This is backside answer. C dash लिखो या c लिखो, that's not important. This is a constant. If you want to do this, otherwise this is fine. ये भी correct है. I'm just telling you backside answer थोड़ा अलग दिखता है sometimes, but you must realize that it is same as what you are getting. I've just shown to you. Fine? Clear? Okay. The next question, dy by dx equals to sine inverse x. So this is about a variable x. So I can write dy equals to sine inverse x into dx. This is which form? Variable separable form. Now we integrate it. Just integrating. So integral of 1 with respect to y equals to integral of sine inverse x on the right hand side. Can you recall how we'll integrate right hand side? If you have a single function which is not known to you, then you can write into 1 and by parts. This is very well known method, you know. You can call this as u and this is v as per Liet rule. Right? Inverse and then algebraic. Inverse come first. Constant means algebraic. So here we do by parts. What's integral of 1? Y. Sine inverse x will come out. What's integral of 1? X minus, inside the integral, differentiation of sine inverse x, 1 upon root of 1 minus x square into इंटीग्रल ऑफ 1 जो आपने यहाँ पे लिखा हुआ है यहाँ पे लिखना है x dx. Fine. So y equals to here x into sine inverse x minus, how we'll do this? This is linear upon quadratic. Now what's the derivative of that quadratic? Minus, you know here, minus 2x. So I'll write here plus 1 by 2 here, and I'll set here minus 2x. Right? And here I'll write 1 minus x square, इसको ऊपर ले लो, raised to minus 1 by 2 dx. अब t लेके भी कर सकते हैं, remember, but I'll use here one of the formula if you remember. What I did here, this is linear upon quadratic. What is the derivative of this quadratic? Minus 2x. So what I did, a minus को अंदर ले लिया, minus multiplying with 2 dividing with 2, so ये हो गया plus. Clear? Now आपको याद होगा एक फार्मूला था, this is f raised to n into f dash. Which formula? F raised to n into f dash, if you remember. Raise the power by 1 divided by the same number plus c. अगर वो नहीं करना है, you take this as t, इसको t ले लो तो भी आ जाएगा. You can just verify here. I'll write therefore y equals to x sine inverse x plus 1 by 2, raise the power by 1, 1 minus x squared, इसका पावर में plus 1 कर दो, so ये हो जाएगा half upon 1 by 2 plus c. Okay, so this half will goes away. So your final integral would be here y equals to x sine inverse x plus, this is root of 1 minus x square plus c. This becomes the required solution here, required solution of the given differential equation. Fine. So here what you noticed, इसके बाद तो आपका इंटीग्रेशन चैप्टर ही चल रहा है, रिमेंबर, इट हैज़ नथिंग टू डू विद दिस डिफरेंशियल इक्वेशंस. अप टू दिस इट इज़ डिफरेंशियल इक्वेशन, राइट? गॉट इट? क्लियर? We go to question number 11 now, 11 to 14. In this question you are asked to find the particular solution satisfying the given condition. So we use this condition at the end. This is sometimes called initial condition. Initial conditions. We use these conditions and we find the value of that constant c. यहाँ तक तो करना ही है आपको. Up to that last point, that is till general solution you are going to do. Then further we want to do with the help of this condition. Okay. So let's separate the variables. Here dy alone, we take this down here, so 2x square plus x upon, what about this, x cube plus x square plus x plus 1 and then dx. This is separation of variables, variables separable form now. Okay, now integration. So now this is the beginning of integration. So here integral of 1 with respect to y equals to, you have 2x square plus x upon x cube plus x square plus x plus 1 dx. Now important part is integration of this. How we'll integrate, that's important part. Okay. So here denominator expression you can just factorize, take x square common from this 2, so x plus 1, and here just 1 common, so x plus 1 dx, right? So here you have 1 dy equals to 2x square plus 1 upon x plus 1 into you know x square plus 1. Now what is this? Product of linear and quadratic expression. So how we'll do this? By partial fraction method, and the degree of numerator should be less than 3, and it is here. So ये तो y हो गया. Here how will write? For this quadratic you need to write linear, so I'll write ax plus b upon x square plus 1 plus constant c upon linear function x plus 1. Which method I've used? Partial fraction method. Okay, now just compare the numerators and take the LCM here. So what I'll get here, I'm just comparing numerators. 2x square plus x here, ax plus b into x plus 1 plus c into x square plus 1. What I did, taking cross multiplication, so both the denominators are same. I've just compared this numerator with, after doing a cross multiplication, you have this numerator. You know this, I'm just reminding you. Now we choose the values of variable x. How many times? 3 times. Why? Because there are 3 unknowns. So first, if x is minus 1 here, this will be just 1, this is 0 here, and this is 2. So therefore c equals to 1 by 2. That's one constant. If next one has to choose what? You know, if nothing is possible, now there is no x for which this is 0, so you need to take 0. So this will be 0. Here this is b into 1, this is 0, so c. So b plus c is 0. But c is 1 by 2, therefore b is minus 1 by 2. You know here, b is minus 1 by 2. Okay. Next, one more. If x is 1 here, put 1 here, so what will get? 3 equals to, if I put 1 here, this is 2 and this is a plus b. A plus b into 2. Here 2c. You know c, you know b. C and b both are known to you. Put here, so we'll get the a, and you will see that a is 3 by 2. Right? Just simplify. A is 3 by 2, b is minus 1 by 2, and c is 1 by 2. So we just put these values of a, b and c over here. So therefore, just look at that step. Therefore y equals to, here, what is a? You know, 3 by 2 x. What's b? Minus 1 by 2. Upon, you have which expression? X square plus 1 plus c. What's c? 1 by 2 upon x plus 1, the whole dx. So therefore y equals to, now this is linear upon quadratic, so I'll split into 2 integrals. 3 by 2 x upon x square plus 1 minus 1 by 2 here. What is this? This would be 1 upon x square plus 1. You can integrate this very easily. And what about the last term? Plus 1 by 2 outside, integral of 1 upon x plus 1. Right? Just do individual integrals. Now these two are very standard forms. This is linear upon quadratic. So what you need to do, you need to set the derivative of this x square plus 1. What is that? 2x. So I'll write here into 2, so here 1 by 2. Okay, so therefore y equals to, this is 3 by 4 f dash upon f log of x square plus 1 minus 1 by 2. What is this? You know, this is tan inverse x plus 1 upon 2. This is linear function. Imagine that as x. So log of x plus 1 plus the constant of the integration. So you have y equals to 3 by 4 log of x square plus 1 plus 1 by 2 log of x plus 1 minus 1 by 2 tan inverse x plus c. This is a general solution. Remember, arbitrary constant is involved. Call this as 1. Now you don't want this, you are asked for particular solution. Now we'll do further. Up to this we did in all previous questions. Now what we'll do further, we get the value of the constant c. Kaise? Using the given condition. Now you are given this when x is 0, y equals to 1. So put in this above equation. So therefore by 1, y 1 है तो ये 1 हो गया. x 0 रखो तो ये log 1 होगा. What is log 1? 0. 3 by 4 into 0. Put 0 here. Log 1. What is that? 0. Put 0 here. What is tan inverse 0? 0 plus c. And therefore 0, 0, 0. And therefore c is 1. And now we write with the value of c over here. So therefore I'll write particular solution y equals to 3 by 4 log of x square plus 1 plus 1 by 2 log of x plus 1 minus 1 by 2 tan inverse x. What's c now? C is fixed, which is 1. Right? This is what you have to do extra. Itna extra karna hai. Now this is not the general solution. This is a particular solution. Value of the constant is fixed 1. यहाँ पे आप कुछ भी ले सकते हैं. How we got this one? Using the given conditions. Fine. In this question also you are given this initial condition, so you need to find the particular solution. First, variable separable form. This is about variable x, so I'll take this one over there. So dy equals to 1 upon x into x square minus 1 into dx. If you realize what is the right hand side expression, it is 1 upon x into x minus 1 into x plus 1. Right, and now we integrate it. So right hand side can be integrated using what? Partial fraction method. Integral of 1 here, you write a upon x, b upon x minus 1 and c upon x plus 1 and finished it. You know how to do this. This is very basic question of partial fraction method. And then after getting the general solution about the constant c, put x equals to 2 and y equals to 0. So I'll get the value of c and then place this. So I'll get the particular solution. 13 number cos of dy by dx equals to a. Where is some constant. Here also you have y equals to 1 when x is 0. What I'll do, this is constant, I'll take over there. So dy by dx equals to cos inverse a, once I take cos on the right hand side. So therefore dy equals to, this is constant, remember, cos inverse a into dx. Now this is in variable separable form, so we just integrate it. So integrating, what's integral of 1 with respect to y? It is just y. This is constant, cos inverse a. Integral here x plus a. I have dropped one step, remember here. Call this as 1. This is a general solution. What I'll do now, use the condition when x is 0, y is 1. So here y is 1, x is 0 and plus c. So we'll get the c equals to 1. Now where we put c? In equation 1. So we'll get the particular solution. So by 1 particular solution is y equals to cosine inverse a into x plus 1. Now c is not there. You have fixed value of c. That's why this is called the particular solution, remember. And here remember, particular solution never contains any arbitrary constant, right? That we already noted in the first exercise. Question number 14 here. dy by dx equals to y into 10x, and you have condition here y equals to 1 when x is 0, right? So we get the particular solution. So first variable separable form, I'll take y down, so 1 upon y dy equals to 10x dx. You take 10x over here, this is which form? Vs form. Now we just integrate it. So integrating, what's integral of this? You know, this very standard form, integral of 10x here. This is log of mod of y. What is this? You know, this is log of mod of sec x, integral of 10. At both the places you have log, so I'll not write just c, but I'll write the logs here, the arbitrary constant. You know this. If everywhere your log function, just instead of c you write the log c. So here log y equals to, take log common, so addition becomes into here. Log you can eliminate, so you have x into sec x. Sorry, c into sec x here. C into sec x. This is a general solution where c is the arbitrary constant. Now we use the initial condition. What about the initial condition here? When x is 0, y is 1. So put over there. So this is 1, c sec 0, which is also 1. So c is 1 here. And therefore I'll write finally particular solution is y equals to sec x.